Hello everyone! In the last video we had a look at what happens when we add a number to a function. But of course we can also multiply a function by some number, and that is what we are going to be looking at in this video. As it turns out, that is going to stretch the graph parallel to the y-axis. So first we'll have a look at what that even means and how we stretch parallel to the y-axis, and then we will have a look at some more examples. So stretching parallel to the y-axis, what is that? What does that even mean? Well, suppose we have this quadratic function, so we have this parabola. If we want to stretch parallel to the y-axis, parallel to this axis, then the stretch is going to be in this direction. So suppose we want to stretch f by a factor of 2. That means that this point at 3 is not going to be 3 away from the x-axis, but 3 times 2, it's going to go to 6. 0, well, that's just going to stay at 0. This point is 1 away, that's going to go to 2 times 1, sorry. 2 away. This one again stays here. And again here, this distance is multiplied by 2 to get this new parabola. Everything is stretched out vertically. The actual shape of the parabola changes. And that's all done by multiplying by 2. So what we're going to do to get our new function is to multiply the old function by 2. And we need to multiply the whole old function by 2, so we have to put it in between brackets. Otherwise we would only multiply x squared by 2, and we also have to multiply minus 2x by 2. So if we remove the brackets, that gives us 2x squared minus 4x, and that is our new function, our new stretched function. So let's try that with some more functions. Suppose we have an exponential function, that's this one. And in this case, we want to stretch it by a factor of 1.5. So the point at 4 goes to 4 times 1.5, 6. Let's see some other point I can read off easily. I have not used a very good example because I can't read off any other points easily, but well, we're just going to do this with all the points, and that gives us this graph. This distance is added another half time. This is another times 1.5, etc. So we have to multiply our old function by 1.5. And well, we just put it in between brackets again, sure. But in this case, there is only one term inside the bracket, so we only have to multiply once. And this one has this x there, we can't really multiply by that, so we are only going to multiply this number. And we're going to get 6, 1.5 times 4, 6 times 0.6 to the power of x. So with exponential functions, this is something to be careful with. You're only going to be multiplying by the initial amount. Let's have one more try. Let's have this linear function this time. Just a straight line. And we want to stretch by a factor of 0.5. We can also have factors smaller than 1, so it's actually kind of squished together. Then this point at 2 is going to go to 1, because it halves. This point at 6 is going to go to 3, etc. And we're going to get this new line. Again, we do exact same thing. We take the old function, multiply it by 0.5, so we get 0.5 times 4x plus 2. And this time, like the previous one, we have two terms. So we have to multiply both terms by 0.5. And we get as our final function 2x plus 1, which indeed is correct. We've got 1 as our y-intercept and 2 as our gradient. So those were a few examples on multiplication of functions. I hope this helps you find the graph of a function after it has been stretched.